Can I set up and explain number one on UT number 21? I certainly hope so. Let's take a look at what we have here. So let's see here. Let's see, number one on UT 21. I think that's the Kirchhoff's laws. That's the systems. Where am I at? I want this, and I can't see anything there. There we go. Okay. All right, so this one here, hopefully you're able to see my screen. The question is on number one, setting it all up. So this one looks very similar to the one that I have on the on my smart notebook file on the PowerPoint. So what I see, and I don't know if I'll use my cursor, I think you can see that. So I see 1, 2, 3 resistors in series with each other across this top branch. So for my example, I've got a 7, a 1, and a 3, those 3 combined. And when I do this one, I'm going to redraw it as a battery on top and a single resistor on top. And since they are connected in series, I'm going to draw a little picture here as well. That's 11. So instead of looking at a 3, 1, and a 7 in my example, I'm going to look at it as a single 11 and a 19 volt battery. The middle branch, I see a 10 and a 2, so I'm going to put in my 27 volt battery. And obviously you need to remember that the long side of the battery is considered the positive and the short side is considered the negative, and that's going to be important depending on how you connect your battery. And the bottom, 3 resistors connected in series, so it looks like that's going to be a 15. I've got a 33 volt battery. So what I say that was 15. So I've got my system there. And that simplifies things a little bit. And obviously you don't need to really do that on paper. You could always just do that in your head. I think you can still see my face when I'm doing this, and I think that gets recorded. So if I do my best, so right about there. So that's what my new picture looks like. So a little bit simplified. So now I'm going to look at each possible loop. So looking at the screen again, so I see that I have a loop on top. I'm going to call that the top loop. I've got a loop down here on the bottom. I'm going to call that the bottom loop. And I have a loop along the outside, so I'm going to call that the outside loop. I see 3 possible loops. And so in setting that one up, I need to guess, I need to predict, I need to just, it's left or it's right, right? All those different pictures there, you got a horizontal wire. So it's either going left or right. So you need to choose, you need to choose a direction. So I'm going to say that the bottom one, since it has a big, huge battery, I'm going to say that that one is pushing to the left, and I'm going to call that one I1. The middle one is 27. It's bigger than 19, so I don't know. I guess I'm going to say that one's going to the left also, which is going to be I2. And those two are going to come together, and they're going to come together right here, and then they're going to flow this direction. So by default, my current across the top has to be going off to the right. I'm going to call that one I3. Say, but that I3 is going the wrong way through the battery. It's going through the positive end and coming out the negative end. Yeah, sure, that can happen. So in my picture, what I literally do is I draw myself a couple little arrows there. So you can see I1 at the bottom, I3 across the top, I2 somewhere there in the middle, so I can actually see those. And I immediately follow that up with a junction rule. The first thing I do once I do that. So in my picture, I've got I1 plus I2 coming together, and those are going to combine together to give me I3. I need that. Otherwise, I can't solve my three equation system with 3 unknowns. I can't solve it. Everything ends up canceling out without that. So I need to have that. And so I'll talk our way through it. I'll put it on a sheet of paper, and then I can show the sheet of paper afterwards. So, and again, looking at my screen here. So I'm going to start with the top loop. Choose a spot and choose a direction, clockwise or counterclockwise. So what I'm going to do is I'm going to start right here with my battery. Hopefully you can see that cursor. I'm going to start with my battery, and I'm going to go clockwise because the current is going this way by my guess. It's going up this way by my guess. So it makes perfect sense for me to go in that direction. So I'm going to start going with the 27-volt battery, and that 27-volt battery, my current is going from the negative end, which is low potential, to the positive end, which is high potential. So that's a gain. So I'm going to call that a positive 27 volt. Now I go through, follow my cursor. I go here, and then the next thing I do is I go through. I've taken all three of these and I've combined them into one. So I can do the resistors first, I can do the batteries first. In my picture, I'll make my picture consistent. In my picture, I have the battery first, and then I drew the resistor over here. So if I go by looking at the battery, I'm going to the right. I'm going from the high side, from the positive, and I'm going through the battery, and I'm coming out on the low end. That's a high potential followed by a low potential. That battery is causing a drop in my voltage. So that's going to be a negative sign, negative 19 in my example. Now I go through my combined resistors over here. It is an 11, and I have predicted current going to the right. And if I go through a resistor with the current, my resistor is going to use up that current. I'm sorry, it's going to use up some of that voltage. And so that's going to be a drop. Think of it as a river. If I go with the current, I go down in elevation, down in potential. So that's going to be a loss. How do I show potential? If I have current and resistance, V equals I times R. So I put a minus sign. I put the resistance R is 11. The current I have called I3. And so I've taken care of the top branch, watching the cursor again. Now I'm coming back down, and now I get to this middle branch to finish it off. I am going with the current, and as I go with the current, that's going to cause a drop in potential. So I have a resistance of 12, and the current I have called I2. So I get minus 12 I2. And all of that has to equal 0 because of the loop rule. Loop rule says when you go through an entire loop, the sum of all of your voltages, and remember, voltage is technically a delta V, all your changes, all of your little changes should give you 0. So there is my new line right there, my top. 27 minus 19, so I can do that. I can put that in and replace it as an 8 instead of a 27 minus 19. So I put any like terms together. And now I've got one equation ready to go. So I can do the same thing for the outside loop. The outside loop looks really similar, as in watching my cursor. I am going with the current, the current goes to the left. It goes up. It goes to the right. These are all my guesses. So I'm going to do another clockwise loop, and I think this one I can go rather quickly. I go through from low to high on the battery. So I'm going to call this the out loop. So I'm going to get a 33. Up here, I'm going through the battery the wrong way again. So that's going to be from high to low. That's going to be a drop of 19, minus 19. I got minus 11 I3 again up here. I come down here, I'm going with the current, so it's going to be another negative sign. So minus, I have 15, and I have I1. So there's my second. So that one was quick because it looks just like the top in terms of how all the batteries and voltages and resistors and currents, they're all set up the same. The weird one for us is going to be the bottom one. So let's wash through the bottom. I'm going to start with my biggest battery here again. I'm going to start there, and I'm going to go with that selected current. So I'm going to go clockwise. But what you're going to notice is my cursor gets right here, and I start analyzing in this clockwise direction. My cursor is moving to the right, but my current was predicted as going to the left. So I am analyzing this branch while traveling upstream. There is nothing wrong with that. That's fine. I just have to realize as I go in that direction, am I losing or gaining? So starting down here with my voltage, my 33 volts, I go from low to high. That's going to be 33. All right. Now I get up here. I get to this battery. I'm on the high side of the battery. Now I'm on the low side of the battery. The direction of the current is irrelevant when I'm looking at a battery. All I want to know is which direction am I moving as I analyze. So in this case, I'm going from the left to the right. I'm going from the high side down to the low side. That's a drop. So as I travel in that direction while analyzing, that's going to be a drop. I now go through the 12 ohms. So I'm going to have 12 as my resistance, but I have to take a look at that current. So looking at my cursor, my current is going to the left. I am moving to the right. I am analyzing this resistor upstream. I'm going from the low side to the high side. That is an increase in potential in terms of where I'm at. Again, it's just like elevation for the river. At the bottom of the rapids, I go against the stream. I get to the top of the rapids. I just gained potential energy. I just gained potential. So that's going to be a plus, what did I have? 12 and an I2. Now I come back down and I finish off this last branch. I'm going with the current. So that's going to be a negative 15 I1 equals 0. So in terms of setting it all up, and I haven't even looked what the question is, but I'm assuming they're asking about current. Yes, they're asking about what is the current in the 19 volt cell. So they're looking at the current. So what I'm going to do now is, and I don't think I need this screen anymore, but I can come back to it at any time. So now I'm back here. So now, okay, center that, there it is. So looking at that bottom, that was the one that was the most challenging. So I've got 3 equations there that I can combine those first 2 terms and every single one of them with some simple arithmetic. And I've got 3 equations. Slide down just a smidge, and there by my finger right there, there is my junction rule. So personally, what I'm going to do is I'm going to take I3 equals I1 plus I2. I'm going to come down here. I'm going to pick one of my I3s and replace it with the 1 plus 2. That's going to give me 2 equations with the same 2 unknowns, I1 and I2, and then I do math. And again, you can use matrices if you want. I just use versions of substitution, and obviously it's all the same, just looking at it in a different way in terms of you using a matrix and me doing substitution. But anyway, I do have an example on there if your math is a little bit rusty. I do have an example on the PDF on how to go about doing something like that. A lot of times you are so, a lot of times you guys are so focused on doing the high level math. When something simpler gets asked, you're like, oh man, I haven't done this in a while. And you got to give it an extra thought. So if that's you, don't be shy, don't be shamed. It happens to everybody. So that's, what was that? That was UT number 21, question 1. And it has some strong similarities with the PDF example that's on there as well. On the problem we just did, the 1 and 2 ohm resistors look like they're drawn smaller than the others. No reason, just trying to probably just squeeze it in with the graphic, or maybe it's a smaller resistors, they just wanted to draw it smaller. So the size in which they draw the little Charlie Brown zigzag pattern isn't relevant about anything. It's just they're just telling you that there's a resistor there. So maybe they draw it smaller because it's a smaller number. Question is, if you guess the wrong direction of current, do you have to redo the question? Nope. If you get guessed wrong, you're going to get a negative current. And you can double check if you want, just to kind of confirm that. But if you set it up properly and you do all your work and you get a negative current, you are going to, that just means the current's going the other way. And to answer, I know why this question is being asked, because when you do this question we just did, I'm pretty sure I intentionally guessed that I2 was going to the left. It's probably going to be going off to the right, actually, based on what I'm looking at there. I have to double check my numbers, but don't be surprised if I2 comes out as a negative. Like, oh, wait, I got a negative there. So a negative just means that if you chose wrong, you get a negative. You get a negative, you chose wrong. And since there's only 2 directions to choose, left or right, getting it wrong is the same as getting it right, because now you know what the answer is. So that is a good question. You have to redo it. If you guessed wrong, nope, you know the answer now. And you can always very quickly and easily just switch out whatever direction was negative, switch it out in your little system there, and try the answer that you got that was negative, put it as a positive, and everything should still work out. Can you further clarify what happens in an open circuit and how it is caused? Well, an open circuit is simply just a circuit that is not connected. So I need a complete circuit, a complete path with some kind of a mover, an EMF, a charge pump. I need that to make charges flow. And so what happens is as soon as I open it, as soon as I make a break somewhere, now I don't have the ability to have charge move through there unless I have so much charge built up that I get a shock or a jump sparking across there, which is why if I have a lot of voltage and I bring things close together, I can get sparks. You shouldn't do this, but if you ever put jumper cables on your car battery and brought them together, you're going to get sparks, just like in the movies, and they're torturing someone and they do that. That's exactly what's going to happen if you do that with your car battery. What you're doing is you are causing a slight, sudden circuit to be connected, and then when the spark stops, it stops, and then when it sparks again, another. So an open circuit is just simply where it's now opened up. If you went in super duper slow motion, and you have a battery that looks something like this, and you connect a wire to each end, but you don't connect anything else. That's an incomplete circuit, nothing's gonna happen. But if we go super slow motion, as soon as you connect this wire to this positive end of the battery, it's going to immediately shoot positives, and you are technically going to end up with a positive, or 2 or 3 or 4 or whatever. You're gonna actually get a positive right here. But what's going to happen is immediately you're going to get this buildup of positives. It's going to produce a reactionary electric field pointing in this direction against the electric field that pushed your charges that way to begin with. And just like that, you do technically get a teeny little bit of flow, but the buildup immediately happens and it causes everything to shut right back down, which is why you can't put in a light bulb here and then connect the wire to it and expect to see even a flash of light. No, the shifting of charge is so quick, and it doesn't take much before everything shuts down. So that's what happens. So one of the concepts that we don't use a lot, at least in RCS, at least at Adams, we don't use the concept of charge density when it comes to a circuit, but there's this concept known as charge density, where as charges flow out of here, you get a buildup of a bunch of positives, and that causes positives to be shot through the battery. I'm sorry, through the light bulb. So there's this concept that I don't like using that concept very much, which is why I don't. But anyway, so when it comes to the question about an open circuit, hopefully that was what you're referring to. Closing the circuit just means connecting everything and having a closed loop. Opening it just means that nothing can flow, and every charge you have is kind of stuck where it's at. So